looking at the axial images from e-anatomy, do take a look at the two different brains that are in with e-anatomy. There's one set that you can go through all three different planes and it has much better detail, and then there's another set that only has the axial images, and these axial images are much thicker, so it makes the brain almost look just a little bit blurry, but sometimes it's nice to see the images in a little bit different version, so I wanted to show you a little bit of each. So we're going to take a look at these images that are a little bit thicker slices right now. We're just coming into the lateral ventricles here, so this is the body of the lateral ventricle, and we are quite superior in the brain here. And then the image on the right, we're just a little bit deeper into the body of the lateral ventricles. So the body is running through right here. We're not quite to the anterior horns yet, and we're just about ready to come into the trigone area here. And then now you can see the anterior horn of the lateral ventricle. So these are the anterior horns here. And this is the septum pellucidum, right between them. We're starting to come into the corpus callosum here. These are the white matter tracts. And we haven't talked about the caudate nucleus yet, but the caudate nucleus follows the anterior horns and the body and the occipital horns of the lateral ventricles, and it is gray matter. Then that's where the nuclei live in the brain. So the nuclei live in the gray matter, and the axons are the white matter, and the axons take the impulses from the gray matter to gray matter. So they're kind of like the highways in between the gray matter. So here we have the anterior horns again and the septum pellucidum, and then we have the foramen of Monroe on each side here, the left and the right. Sorry, excuse me, the right and the left coming into the third ventricle. And then these are the posterior or occipital horns of the lateral ventricles, and we're going to see them come all the way back here. We're not going to see them on these images because, again, these are not the more detailed images, but you can just start to make out the posterior horn. So this is a trigone area here. And then on this image here, you're just catching a little wisp of the temporal lobe, temporal horn in the temporal lobe of the brain. So you see the left temporal horn and the right temporal horn, just catching just a little bit of that in this image, just because it is a thicker slice. So talking through the language of the third, fourth ventricles and the foramen of Monroe and aqueduct of Sylvius. So the third ventricle and the fourth ventricle are singular midline sagittal structures. So the third ventricle is a midline structure. It's thin. The thalamus sits on either side, so it's bound by the thalami laterally. A central space for interthalamic adhesion, which is right here, and it connects the sides of the thalamus together. And it connects the fourth ventricle here to the aqueduct, or it connects to the fourth ventricle through the aqueduct of Sylvius, or also called the cerebral aqueduct. And the fourth ventricle is a midline structure within the cerebellum. So the cerebellum sits here, and this is the fourth ventricle. Becomes continuous with the spinal canal through the obex. And this would be the obex going into the central canal. And you've got the foramen of Luschka here and the foramen of Magendie. And those allow the CSF outflow into the subarachnoid spaces. So the foramen of Monroe up here connects each lateral ventricle, remember the two on either side, connects each lateral ventricle to the singular midline third ventricle. And that's just posterior to the septum pellucidum. This right here is just posterior to the septum pellucidum. And also inferior, because the septum pellucidum runs right between the lateral ventricles. And the aqueduct of Sylvius here, or also called the cerebral aqueduct, connects the third ventricle to the fourth ventricle. It's anterior to the quadrigeminal or tectal plate, and we'll see that on an image coming up here, a sagittal MRI image. In this image from e-anatomy, you can see a midline T1 sagittal brain, and the anterior portion of the patient here has been cut off, but this is the anterior portion of the face, and posterior portion, superior and inferior. And you can see the cerebral hemispheres here right in the midline. You can see the corpus callosum, which we have not studied yet, but this is a corpus callosum. And the third ventricle is here, and you can see the intrathalamic adhesion. You can see that little bit of the thalamus that connects both sides of the thalamus. And then here is the aqueduct of Sylvius, or this Sylvian aqueduct, or cerebral aqueduct. And then just posterior to that, as we mentioned in the last slide, is a tectal or quadrigeminal plate. So aqueduct of Sylvius and tectal or quadrigeminal plate. And then this is the fourth ventricle, and this is the foramen of Luschka and the foramen of Magendie. And then this would be the obex right here, right anterior. So you can see how those two structures are so close to one another that I'm going to be pretty lenient on the exam for that particular question. Now we have some T2 weighted images, T2 weighted MRI scans, so that you're able to see the CSF spaces in a bright signal. So they're sometimes easier to identify that way. So taking a look at this image on the left, you've got the anterior part of the patient, posterior, right and left. And these are the anterior horns of the lateral ventricles, and the septum pellucidum just midline to that, medial to that. You've got the foramen of Monro, the right and the left foramen of Monro, the third ventricle, and the trigone area, the left and the right trigone area of the occipital horn of the lateral ventricles, and then this is the choroid plexus within the trigone area of the lateral ventricles. Taking a look a little bit inferior to that, here on this image on the right, you can see the temporal loans of the temporal horns of the lateral ventricles. So these are the temporal lobes of the brain, and then these are the temporal horns of the lateral ventricles. And you can see how sometimes you just clip a little bit of the image and you're not able to see the full temporal horn. Partly that is also because it is moving inferior and anterior as well as laterally, so it would be hard to catch it unless you were angling specifically to see the temporal horns. And then moving more inferiorly than that, you can see how we're more into the mid area of the globe of the eye here. Here we are more superior in the globe, but in this image here in the middle, you're more within the midline portion of the globe of the eye. And you can see the pons here. We've not studied that yet, but the pons. We're still within the temporal lobes of the brain here. And then we have the cerebellum. And you can see that by these little striations. That's very indicative of the cerebellum. So you know you're within the cerebellum when you see that. And then cerebellar peduncles are what connects the cerebellum to the pons. You've got cerebellar peduncles, and then we also have cerebral peduncles. And we'll be studying those a bit later. And then within that cerebellum is the fourth ventricle, and here you can see that here. So you can look for your bright CSF spaces, and then you're able to more easily place the structures around it. And then just reviewing the most inferior portion of the lateral ventricles, the foramen of Luschka. It is here, here, superior to the foramen of Magendie. Remember that L, Luschka, comes before M, Magendie. Also, Luschka is the lateral foramen. So Luschka is lateral. That's the other way to remember it, L and L together. And then foramen of Magendie is inferior to the foramen of Luschka and also allows the outflow of CSF. Magendie is the median or medial aperture, median or medial foramen. And then the obex is what connects the foramen of Magendie and the fourth ventricle into the central canal to allow CSF flow to bathe the central canal and also cushion it. The CSF flow bathes and cushions the spine and the brain. And that will be the review of our ventricles.